Hello there, welcome to this simulation using the lab pad as an important way to get the most out of It's so good you're here. Some of my colleagues have asked me to help them to prepare a very precise solution of NH4Cl, also known as ammonium chloride, which they need for a chemical analysis they are doing, and I could really use a hand. Will you be able to help me prepare the solution they need, using the right equipment? If so, let's get you suited up for lab work. Find a lab coat and pick it up. Well done. Now find a glove box and click on it to wear. In a lab, you should also wear safety glass. Alright, now you're all set. Enter the highlighted lab room to the left. Your mission today will more specifically be to prepare a 500 milliliter aqueous solution of ammonium chloride at 0.300 molar. Ammonium chloride is a salt with a very high solubility in water. You have probably eaten it at some point, as it is actually being used to flavor some kinds of licorice. That doesn't mean it's safe for you to eat the pure compound or drink the solution though. As your solution has 3 significant digits, you need to be very careful and use the right equipment to ensure the concentration is accurate. Let's first figure out the mass of ammonium chloride you need for your solution. Let's start by figuring out the amount needed in moles. From there, we can easily find the equivalent mass. Which equation do we need to find out how many moles of ammonium chloride would there be in 500 ml? That's right, we need N equals C times V in our... Alright, how do we then get from moles N to mass M? I'll give you a hint, you're going to need the molar mass capital M. Indeed, the conversion between moles... Pick up the spatula. Well done, now put the spatula back again. Haha, I'm just messing with you to see if you understand how to interact with things in this simulation. Alright, I want to go over 2 important points with you here at workbench 1. Firstly, you will need to use the analytical balance to weigh out a mass with high accuracy. When using the analytical balance, it's important to note a few things. 1. Before adding any substance, first place a weighing dish on the balance and tare it. 2. Always close the door before making a reading or tarring it. 3. Always remove the weighing dish from the balance and place it on the workbench before adding anything. 4. Always note exactly what the balance says. This is what determines your final concentration, not the number you plan to reach. Secondly, I've set up a handy red button for you, both here on workbench 1, and on workbench 2 in the next room where you'll go a little later. Whenever you click it, I will reset the materials on the workbench you're at, and take you back to the most recent checkpoint task for preparing the solution. If you ever get stuck because you did something in the wrong way, or want to experiment a bit, just click the button to try again. And don't worry, I won't make you restart completely, but be careful with it still. Clicking it will also reset your workbench even when things are going well. Let's get started with the solution, shall we? Put a weighing dish on the analytical balance, close it, and click tare to reset it. Weigh out 8.024 grams of ammonium chloride using that weighing dish. Remember to place the weighing dish on the workbench before adding any ammonium chloride. Make excellent work. What was the first step of using the balance, before adding anything to a weighing dish? That's right, only then do you get a good starting point for accurately. Okay, you now have the right amount of salt ready. I made it easy for you to dispense the amount with the spatula. In real life, make sure to be really careful with getting the amount correct. The balance's display might not read exactly 8.024, but remember, the weighed-off mass only has to be precise enough for us to yield a solution at 0.300 molar, which has 3 significant digits. A crucial decision awaits you concerning which container to use for getting the concentration just right. Take the weighing dish with weight-off salt to workbench 2 in the next room. Put the weighing dish on the workbench. You now have to choose what glassware you want to prepare your solution in. Which one do you think is fit for this purpose? Choose the piece of glassware that you want to use for prepare. Good job! Now why is it that the volumetric flask is the right choice here? You're right, it's very easy to add and mix different substances in the volumetric flask, and also achieve a very precise final volume and thereby a very accurate concentration. Put the volumetric flask on the workbench in front of you. It's now time to actually prepare the solution. I will walk you through it step by step. It can be really difficult to get the salt directly from the weighing dish into the volumetric flask. So we'll first add it to a beaker. I created a new one for you here on the workbench you can use. Nice. As a bit of the salt can easily be left in the weighing dish, to make sure we transfer everything, also called to transfer quantitatively, you need to wash the weighing dish with the solvent of the solution you're making, and also transfer this to the beaker. Sweet. We now have most of the salt transferred to the beaker. Since we want to be really accurate here, please wash the weighing dish one more time. Wash the weighing dish again, and transfer the wash to the beaker. Now please transfer the content of the beaker to the volumetric flask. Alright, now you actually have an aqueous solution of your salt. Though perhaps not all of the salt has dissolved yet, but we'll get to that. How sure would you say you are about the concentration at this point? Exactly. Right now, we're only able to make a rough estimation of the current concentration. Before we proceed, I want to focus a little on how you determine the current volume of a liquid in containers like volumetric flasks, measuring cylinders, and so on. They all have horizontal lines that mark certain volumes of the container. On a volumetric flask, it may look, most common liquids, like water and ethanol, have a concave meniscus, which means that the liquid crawls up along the edges of the container. Note that some liquids actually have a convex meniscus, where the liquid is at its highest in the middle, not at the edges. For those, it's important to do the reading at the top of the meniscus instead to get an accurate reading. Before filling the bottle all the way to the mark, we first need to make sure the salt is completely dissolved. Otherwise it will take up space now, but not later on when it's dissolved. This would make the concentration less accurate. Do this by first adding a large portion of the water to the volumetric flask, but less than the total volume, and mix the contents by turning it upside down a few times. Add a large volume of distilled water to your solution using the large distilled water bottle. Well done. Adding anything to a volumetric flask can sometimes be difficult, because its neck is so narrow. In real life, you always have the option to use a clean funnel. Pick up the volumetric flask to mix the solution. Put the volumetric flask back on the workbench. Time to fill the flask to the mark. It's really important not to fill over the calibration mark, because then you would have to start over. Use the small water bottle to slowly add water, until it reaches the mark. Use the small water bottle to fill the volumetric flask to the mark. Great. Pick up the flask again to mix the final solution. Awesome. The solution is now prepared to the right concentration, and thoroughly mixed. Before we wrap up, you have to store your solution. It's not very practical to store anything in a volumetric flask, so we often transfer it to a blue-capped bottle. You also always label a storage bottle with, at least, its contents. It's often a good idea to also add the date it was prepared and your initials. I've created a new bottle on the workbench you can use. Put the flask back on the workbench. Mark the storage bottle with its new content. Great. Throughout this simulation, you've been working with molar concentration. Sometimes, concentration is expressed by mass instead, so the unit is, for example, grams per liter. Everything works exactly the same way, the amount is just tracked in grams instead of moles. The concentration by mass of your ammonium chloride solution is 16.0 grams per liter. Before I let you go, let's see if you can get this last question. What do you do if you add a bit too much solvent when filling the volumetric flask to the mark? Awesome, you're right, of course. There's really no good way getting around starting over if you add too much solvent to your solution while preparing it. That's all for solution preparation. Thank you so much for helping me out, you did great. Normally, it would now be time for you to clean all of the lab equipment you've used. Don't worry about it though, in this simulation, I'll take care of it. Let me ask you